In the early 1950s, the race to dominate diesel-electric locomotives reached a fever pitch. American Locomotive Company, known as Alco, had carved a reputation for powerful, reliable engines that roared across the nation's rails. Yet, on the horizon, a revolutionary force emerged from General Electric. The GE engine that would redefine the industry combined cutting-edge electrical systems with unmatched reliability, offering railroad companies higher efficiency, lower maintenance, and unprecedented operational flexibility. Its introduction transformed locomotive design, reshaped freight operations, and marked a turning point in the battle for supremacy on America's railroads, a moment when engineering precision met strategic foresight, altering the trajectory of an entire industry. The conclusion of World War II marked the beginning of a transformative era in American railroading. For over a century, steam locomotives had been the backbone of freight and passenger operations, powering the nation's economic growth and connecting distant regions. Steam engines offered immense pulling power, but they demanded frequent maintenance, large crews, and constant attention to fuel and water supplies. Diesel-electric technology, which had been under development since the 1920s and gained traction in the 1930s, had demonstrated its advantages during wartime rail operations. Railroads observed that diesel-electric locomotives could operate longer distances without refueling, required fewer crew members, and delivered more predictable performance under varying terrain and weather conditions. The post-war period saw a rapid modernization of railroad fleets. Railroads sought engines that could handle heavier freight, reduce operational costs, and maintain schedules with precision. The need for reliability and efficiency became the defining criteria for any new locomotive. In this context, the American Locomotive Company, Alco, had already built a strong reputation. Its 244 series diesel engines powered some of the most iconic locomotives of the late 1940s and early 1950s. The RS-3 road switcher, favored for its versatility, could move freight across branch lines and main lines with equal competence. Meanwhile, the FA and PA series brought Alco's engineering into the passenger arena, combining aesthetics with robust power to move long-distance trains with confidence. Alco's engines featured advanced mechanical designs, including high-speed turbocharged four-stroke diesels, which delivered horsepower sufficient for demanding freight service and reliable passenger schedules. Railroad operators appreciated the durability of Alco engines, particularly in regional service where maintenance facilities were less developed and locomotives needed to be self-reliant. However, the post-war diesel boom also intensified competition. Electromotive Division, EMD, leveraging experience gained from the FT series during the war, offered reliable, low-maintenance engines that quickly won over many railroads. Meanwhile, General Electric, historically a leader in electrical systems, began developing engines that integrated cutting-edge diesel mechanics with superior electrical traction technology. Both companies implemented innovations to improve efficiency, reduce operational interruptions, and increase total horsepower per unit, pushing Alco to respond to a rapidly evolving market. The result was a diesel revolution that transformed the very landscape of American railroading. Railroads began to prioritize engines not solely on horsepower, but on long-term reliability, modular maintenance, fuel efficiency, and the ability to handle complex freight patterns. Alco's contributions remained significant, but the stage was set for a new era where electrical integration, advanced diesel design, and operational economy would define locomotive success. General Electric's entry into the diesel locomotive market represented a strategic leap in both engineering and market positioning. Unlike traditional manufacturers, GE leveraged decades of experience in electrical systems, ranging from industrial generators to traction motors, to create a locomotive that combined mechanical power with electrical precision. The company recognized that the future of railroading would depend not only on raw horsepower, but on the ability to manage that power efficiently, reliably, and across increasingly long and heavy freight trains. In the early 1950s, GE introduced the 7FDL series, a four-stroke, turbocharged diesel engine designed to integrate seamlessly with advanced DC generator technology. The 7FDL engine delivered consistent high horsepower while maintaining fuel efficiency, allowing railroads to operate longer trains with fewer locomotives. Each unit provided precise power delivery to the traction motors, reducing wheel slip and optimizing adhesion, which was particularly important on steep grades and in heavy freight service. The 7FDL series featured a modular design that revolutionized maintenance practices. Components such as cylinder blocks, fuel injectors, and turbochargers could be replaced individually, allowing rapid overhauls without removing the entire engine. This design minimized downtime on busy freight corridors and increased overall fleet availability, a key consideration for Class 1 railroads operating on tight schedules and high-density routes. Beyond mechanical and electrical integration, GE focused on operational flexibility. The 7FDL engine excelled in multiple unit MU operations, where several locomotives are controlled from a single cab. This capability allowed railroads to assemble longer, heavier trains without requiring additional crews, improving operational efficiency and reducing labor costs. GE's electrical control systems ensured that power was distributed evenly among all units, creating smooth acceleration and braking performance under diverse conditions. The 7FDL series was deployed in a wide range of locomotive types, including road switchers, freight hauling units, and passenger locomotives, demonstrating versatility across multiple operational scenarios. Railroads quickly recognized that GE's approach combined reliability, maintainability, and power efficiency in a package that set new industry standards. Through the combination of advanced diesel mechanics, cutting-edge electrical systems, and modular engineering, General Electric reshaped expectations for locomotive performance. The 7FDL series established GE not merely as a competitor, but as a transformative force in the diesel era, creating a foundation for decades of innovation and a decisive advantage in the competition with established manufacturers like Alco and EMD. The introduction of the GE 7FDL series marked a significant advancement in diesel-electric locomotive performance, offering measurable technical advantages over Alco's 244 engines. Railroads evaluated locomotives not only by horsepower, but by operational reliability, maintainability, and overall efficiency. In these critical areas, the 7FDL established new benchmarks. Power delivery. The 7FDL engine delivered steady, reliable horsepower across long hauls, regardless of terrain or load. Its four-stroke, turbocharged design allowed locomotives to maintain consistent speed while hauling heavy freight trains over mountainous regions or long grades. In contrast, Alco's 244 engines, while powerful, occasionally showed variability in output under extreme operational stress. The 7FDL's ability to sustain continuous high horsepower made it ideal for demanding Class 1 freight corridors, where consistent performance directly influenced scheduling and tonnage capacity. Electrical control. GE leveraged its decades of experience with traction motors and generators to create a system that maximized locomotive adhesion and minimized wheel slip. Each 7FDL-powered unit paired a high-capacity DC generator with multiple traction motors, providing precise control of power distribution. This capability proved critical in heavy haul operations, including coal, ore, and bulk freight, where optimal traction reduced track wear and enhanced safety. Railroads recognized that GE locomotives could handle long, heavy trains with smoother acceleration and braking, improving operational efficiency across entire networks. Modularity and maintenance. Maintenance efficiency became a defining strength of the 7FDL series. Its modular construction allowed individual components, cylinder heads, turbochargers, fuel injectors, and other critical systems, to be replaced quickly without dismantling the entire engine. This design significantly reduced downtime during repairs and overhauls, increasing locomotive availability and reliability. In contrast, Alco engines required more extensive maintenance procedures, often leading to longer service interruptions and higher operational costs. Fuel efficiency. Operational tests demonstrated that 7FDL engines consumed less fuel per ton-mile than comparable Alco engines. This efficiency resulted from the combination of advanced diesel mechanics and optimized electrical systems, allowing locomotives to convert fuel into traction more effectively. For railroads, fuel savings translated into substantial cost reductions over the lifetime of a locomotive, reinforcing the 7FDL's appeal for large-scale freight operations. These technical advantages allowed GE to position its 7FDL-powered locomotives as the preferred choice for Class I railroads operating long-haul, high-density freight services. By providing a combination of sustained horsepower, superior traction control, modular maintenance, and fuel efficiency, the 7FDL redefined performance expectations for diesel-electric locomotives and created a new standard that Alco and other competitors would strive to meet. The introduction of the GE 7FDL series quickly translated into widespread adoption across North America. Railroads recognized that these locomotives combined reliability, efficiency, and operational flexibility in ways that optimized freight operations. Among the earliest adopters were the New York Central, Union Pacific, and Atchison, Topeka, and Santa Fe railroads, all of which deployed 7FDL-powered units in substantial numbers. These locomotives were put to work across diverse terrains, from the flat agricultural expanses of the Midwest to the steep grades of the Rocky Mountains and the Sierra Nevada. In these challenging environments, 7FDL engines demonstrated consistent performance, handling heavy coal, ore, and intermodal freight trains with smooth acceleration, steady speed, and precise traction control. Operational testing and daily service showed that GE-powered locomotives could maintain high tonnage over long distances without excessive wear on engines or track infrastructure. A critical factor in GE's market success was its strategic partnership with Electromotive Division, EMD. While GE specialized in electrical systems and diesel engine design, EMD provided complete locomotive packages, including chassis, bodywork, and drive systems. This collaboration allowed GE to offer turnkey solutions that met railroad specifications without requiring additional integration or engineering. Railroads received locomotives that were immediately operational, reliable, and supported by existing maintenance infrastructure. The combination of technological innovation and operational convenience made GE-powered locomotives a preferred choice for new orders, particularly for Class I railroads managing long-haul, high-density freight. Railroads appreciated the cost savings achieved through fuel efficiency, reduced maintenance downtime, and labor efficiencies provided by multiple unit operations. Over time, the 7FDL series became the backbone of many freight fleets, setting a new standard for diesel-electric performance and influencing procurement decisions for decades. By establishing both a technological and operational advantage, GE not only captured market share from Alco, but also redefined expectations for locomotive performance. Railroads began to prioritize modular maintenance, electrical reliability, and fuel efficiency in their future acquisitions, shaping the trajectory of diesel-electric operations across North America. The post-war diesel market of the 1950s and 1960s was a highly competitive arena, with General Electric, Alco, and Electromotive Division vying for dominance. Each manufacturer brought distinct strengths to the table, reflecting different engineering philosophies and operational priorities. Alco engines earned a reputation for ruggedness and high mechanical horsepower. The 244 series engine powered versatile locomotives such as the RS3 road switcher and FA/PA passenger units, which were capable of handling diverse service requirements. Alco's engines excelled in raw pulling power, particularly in heavy freight service and regional operations where mechanical strength and durability were critical. However, the 244 engines required frequent maintenance and specialized care to maintain peak performance. Extended service intervals were challenging under heavy operational stress, which occasionally increased operational costs for railroads. Despite these demands, Alco's engineering contributed significantly to diesel development and helped railroads transition from steam with reliable high-power locomotives. EMD leveraged wartime production experience and extensive research to dominate both passenger and freight markets. Its 567 series engine, followed by the 645 series, combined reliable diesel mechanics with user-friendly maintenance procedures. EMD's extensive dealer network provided rapid support and parts availability, ensuring minimal downtime for railroads. The engines performed consistently in multiple unit operations, long-haul freight, and passenger service, earning a reputation for operational dependability. EMD's designs emphasized balance between horsepower, efficiency, and maintainability, establishing a standard that competitors had to match. General Electric differentiated itself through the 7FDL series, which integrated superior electrical systems with advanced diesel engineering. GE's locomotives delivered precise traction control, smooth power distribution, and consistent high horsepower under heavy load. The modular engine design allowed rapid maintenance, reducing downtime and increasing fleet availability. GE engines performed exceptionally in multi-unit operations, long-haul freight, and high-density industrial routes. Fuel efficiency, reliability, and electrical integration made GE units particularly appealing for Class I railroads seeking long-term operational economy. When comparing the three manufacturers, GE's advantage lay in combining mechanical power with advanced electrical control, while EMD excelled in reliability and support infrastructure. And Alco stood out for raw engine strength. Railroads evaluating lifecycle costs, operational flexibility, and performance increasingly favored GE and EMD designs, which contributed to GE's rapid market expansion. Over the decades, this trend established the 7FDL series as a defining standard for diesel-electric locomotives, while Alco's presence gradually diminished, despite its historical significance in the evolution of diesel technology. The GE 7FDL series stands as one of the most influential families of diesel-electric locomotive engines in North American railroading history. Introduced in the mid-20th century, the 7FDL series was initially designed to meet the growing demands of heavy freight transportation across vast and varied terrains. Over the decades, the engine underwent continuous evolution, reflecting GE's commitment to performance, durability, and adaptability. Early iterations of the 7FDL focused on providing a reliable power plant for medium to high horsepower locomotives, but as railroads' needs expanded, GE responded with incremental improvements in horsepower, cooling efficiency, emissions management, and traction control systems. One of the most significant developments came with the 7FDL 16 variant. This 16-cylinder powerhouse delivered between 3,000 and 3,500 horsepower, enabling locomotives to haul heavier freight over long distances without the need for excessive multiple unit consists. The 7FDL 16 became a mainstay for several of North America's largest freight operators, powering iconic locomotives like the GE U30C and C30-7. Beyond raw power, these engines were known for their exceptional reliability, even under the stress of continuous high-tonnage operations in extreme weather conditions. From the frozen expanses of the northern plains to the sweltering deserts of the southwest, GE's success with the 7FDL series had far-reaching consequences for the entire locomotive industry. The company's focus on electrical integration, particularly the seamless pairing of diesel engines with advanced traction motors and control systems, set new benchmarks for efficiency and performance. Railroads increasingly prioritized engines that were not only powerful, but also modular and maintainable, allowing for easier overhauls and reducing downtime. The 7FDL's longevity and compatibility with evolving train control technologies gave railroads operational flexibility and minimized life cycle costs, making it an attractive choice for decades. Perhaps the most enduring legacy of the 7FDL series is its influence on modern high-horsepower diesel-electric locomotive design. Many principles pioneered by GE, robust modular construction, emphasis on electrical system integration, Advanced cooling systems and gradual horsepower scaling continue to underpin contemporary locomotive engineering, even as AC traction, microprocessor controls, and emissions-compliant engines dominate today's fleets. The 7FDL series remains a reference point for reliability, performance, and innovation. In essence, GE's 7FDL engines helped shape the trajectory of diesel-electric locomotives, leaving a lasting imprint on North American railroading that endures in the locomotives rolling across the continent today.